Hello doctor, my name is Lim Wan, and this video I will present about my final program of the lab 3, which is the part 2C. And the objective of this program is to combine our previous two programs, which are the hexagon parameter calculator and the array sum calculator, into one single application. Instead of running them separately, we built a main menu to allow the user choose their mathematical operation they want to run. To make this work, we use comparison instruction and conditional jump to control the flow of the program based on the keyboard input. So we start with the data section of the code. So first we set up the text string of our main menu. So this includes the welcome message and selectable option. The prompt will ask again for the input, and there are some formatted to perfectly match the sample output in the lab suite. So below the menu text, we kept the variable of the program 1 and program 2. You can see the 32-bit D-word variable for the hexagon side, and our 6-element hello array to hold the integer input. Keeping everything in one data segment makes it easy for the program to access memory no matter which menu option is selected. Scroll down to the code segment, and the program begins with the main menu loop label. So the very first instruction is the call clear screen, which will clear the console screen to be clean, and then print the menu option to the screen using call red string and capture the user choice using call read decimal. The choice is stored in the EAX register. Here's where the branching logic happens. We use compare instruction CMP to check the value of EAX, and if the user type 1, the JE instruction jumps straight to hexagon code, and if they type 2, the JE instruction jumps to array code. If they type anything else, the program safely hit the unconditional jump main menu loop at the bottom, which simply reload the menu. And scroll down to the parameter hexagon loop, add, and the calculate sum odd even label. So when the programs jump to either the hexagon task or the array task, it clears the screen again so the user has a clean workspace. So the mathematical logic remains unchanged, exactly the same as our program 1. So for the hexagon, we loop 6 times to add the side together. And for the array, we jump 8 bytes forward in memory to separate the even and odd indices. However, notice what happened at the end of this task. Instead of using the exit command to close the program, both tasks end with jump ask to continue. This pushes the user our navigation gateway. Under the ask to continue label, we ask the user if they want to return to the menu or exit. We use the call read char procedure here, so because it instantly reads the single key pressed without requiring the user to hit enter. We compare the input character against both lowercase and uppercase letter. If they press Y, way back to the main menu loop, and if they press N or N, capital letter, we jump to exit program, print the goodbye message, and close the program. So this is the output for the program, and I will start with the option 1. So I will also input the value of the side length for hexagon 1 and hexagon 2. So the result of the parameter of hexagon 1 and hexagon 2 will be printed here, and the total parameter of hexagon 1 and hexagon 2, which is the sum of these two parameter of hexagon, will be also printed. So if I press Y, the program will back to the main menu for us to reselect the option. So now I will go with the option 2, and I will input a number. The program will correctly identify the sum of the even and odd index location. So finally, I will press the N to trigger the exit routine. So the message of the goodbye and thank you will be display here for the program to be ended safely. So that's all for the program of the part 2C. Thank you.